induction. All right, so first we're going to start with how to write the statements. Okay, so here we go. Is this like? Okay. Okay. All right. So again, 3 steps. Here we go. If let's say S is a statement and N is any integer within that statement, so like the first statement, second statement, third statement. If S1 is true and SK is assumed to be true, then the truth of SK plus 1 is going to prove the entire statement of S to any integer, S to any number. So again, prove, assume, prove, done. Okay? Okay, so prove the first. Oh, you're good. Okay, because I'm going to do it like 17 times today. Here we go. All right. P.S. Depending on which book I took the problems out of, sometimes it was S for statement, sometimes it's P for proof. I don't know. So S1, P1, whatever. All right. Here we go. Yeah, again, 3 steps. Yeah? Okay. Here we go. So step 1, for the given statement. So this is a statement. Sn is equal to some infinite, or not infinite, but some finite expression, and it gives you expression for the sum of the whole thing, right? So we're going to practice writing the 3 statements that you need to prove. Yeah? First of all is S1, right? So S1 basically is the first term. So is 1 equal to 1 times 1 plus 1 divided by 2? Yeah, so true. That's it, right? So S1 is the first term. True? So SK. SK would be 1 plus 2 plus 3 plus ... plus K. That's your last term. Is equal to, wherever you see an N, just plug in K. So K plus 1 over 2. We're going to assume that's true. Okay? And then the last term that you have to show is SK plus 1. So if you can imagine, it's 1 plus 2 plus 3 plus ... plus K plus 1. Like that? Yeah? Which, if you plug in K plus 1 where you ever see an N, it would be K plus 1 times K plus 1 plus 1 divided by 2, aka K plus 1 times K plus 2 divided by 2. And so the steps go prove, assume, then prove that's a true statement. That's what we're going to do. So if you can get those 3 statements, we're good. Well, we're going to show you how to do the whole proof in a second. This is just, these are what your statement should look like. Okay? Okay. Because I'm going to reuse these examples to write out the whole proof. Yeah? Yeah. Nah, because in geometry you had to be like, angle A is equal to angle B because alternate interior angles are something like that, right? This is a little different. Yeah, so this is going to push us into sequences and series, basically. Yeah. So smart. All right. Statement 1. Yeah? Is just 1 squared. Is that the same as 1 times 1 plus 1 times 2 times 1 plus 1 divided by 6? It is. So that's true. Okay? Yay. Usually the first statement is true. And if they're telling you to prove it, that's probably a true thing. So basically, if you don't get to where you're at, just go back and fix it because usually it's supposed to be a true statement. Okay? So SK is going to be 1 squared plus 2 squared plus 3 squared plus ... plus K squared, which if you plug in K's everywhere will be K plus 1, 2K plus 1, all over 6. That'll be the second statement. Okay, and then the last one, SK plus 1 would be 1 squared plus 2 squared plus 3 squared plus dot 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 plus, to put the k squared, I'm just going to go to k plus 1 squared, say for root, that should be, whew, holy Moses, alright, k plus 1, put in k plus 2, and if you put in k, 2k plus 3, yeah, that's good. All over 6. That's true. Okay? So now that you know how to write the three statements, let's do the entire. Right? So you gotta go prove, assume, prove, and last statement, therefore, Sn is true for all positive. So 3 steps, and then just say that it has to be. Okay. All right. Here we go. So starting with that first example. Ready? Full proof. Yes, love. So that's what I'm saying. If it usually for the IQ questions, it can't be true. I know I made a mistake in last quiz where it was not true. The first one wasn't true. In which case that's not provable, but that was because I made a mistake. But usually always. Okay. Okay. All right. So first, it's kind of like write an essay, right? You need an introduction. Introduce the statement. So you say let Sn be 1 plus 2 plus 3 plus dot 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 plus n equal n plus 1 over 2. Okay, so you introduce the statement. Yay. Okay. The next piece. The next piece, you can number it if you want to. I like to number it, but you don't have to. I like to number the steps. So step 1, right? S1 is such that 1 is equal to 1 times 1 plus 1 over 2. Therefore, S1 is true. Right? You have to say S1 is true. Show that S1 is true, and then say S1 is true. First paragraph. Well, after. Okay? Oh goodness. Here we go. The second step is my favorite line. Because all you have to say is assume SK. Oh, blah, 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 blah. Nope. Okay. Let me do this. It's supposed to be little k, please. Here we go. Assume SK is true. Right? So you say assume it's true, and then you have to say what SK is. So SK is 1 plus 2 plus 3 plus dot 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 plus K is equal to K times K plus 1 over 2. Okay. Now we just have to assume, now we have to prove SK plus 1. Here's how you do it. You add K plus 1 to both sides, and you solve the right side, and it should end up SK plus 1. Here's what I do. Here we go. Step 3. By adding K plus 1 to both sides, dot, dot, dot. Here we go. You would get 1 plus 2 plus 3 plus dot, dot, dot plus K plus K plus 1, which is equal to this thing, right? The previous statement plus K plus 1. So K times K plus 1 over 2 plus K plus 1. So again, just to recap, all I did was take the SK statement and added K plus 1 to both sides of the equation. Yay? Fractions. Hello. Common denominator. Oh, we're just trying to prove that if you add K plus 1 to both sides, then you get SK plus 1. Right? And let me go back really quick. SK plus 1 looks like this, right? So if you can get that second side to look like this, that's sk plus 1. Yeah, alright, here we go. So again, all I did was add k plus 1 to both sides of the k statement. That's it. Yeah? And then you just simplify this side. Yeah, so you just simplify this side. Yeah, in South Korea. Yeah! Hey! Common denominator is 2. So it goes k plus 1 plus 2k plus 1 all over 2, because you just need to multiply top and bottom by that. Truth? Okay. Which is equal to k plus 1, 2k plus 2 all over 2. Is that sk plus 1? Did you do it? Nope. I messed something up. What did I do? Where's the k go? Oh, no, that. Okay. Nope, let me do this. Sorry about that. Delete. Nope. I need it to look like 2k. Oh, yeah. Oh, okay. Here we go. So, you'll notice that there's a common... Oh, yeah! There's a GCF. K plus 1. Yeah. This is equal to, yeah, k plus 1 over 2 times k plus 2. Right? Right? Because the GCF is k plus 1 over 2. Okay. Which is the same thing since it's multiplied as k plus 1 times k plus 2 over 2, which is equal to sk plus 1. Yeah. Well, I couldn't get the k plus 2 unless you did that. Oh! Yeah, I guess it's the same thing. Yeah, it's the same thing. Yeah? Now, you have to have a conclusion. Alright? Here we go. Don't get lazy with the conclusion because that's definitely a method. Alright, here we go. That's like a free point. You say, therefore, by mathematical induction, Sn is true for every positive integer n. So make sure you have your introduction and your conclusion. Yes. So the question I had last year is like, what if you get the whole middle part wrong and then you said the first time? They're points. They're points. Yeah. Guess what?
So if you write this sentence,
I mean, point. Well, I mean, I would because it's a much.
but if you write this sentence,
You have to actually. You actually have to show some type of mathematical induction and then close the sentence.
so like if you quote 1 plus 1.
So 1 point out of 12 is like.
But like you got 1 point.
You got, yeah. Yeah. So that's what we did right here is, well, it's good to, so while you're working on your proof, is to write your 3 statements like off to the, to like on a separate sheet of paper. And then that's how you know that's what you need to get to. You know what I mean? And then when, that's like your rough draft, final draft. Yay? So the question was, do you have to work out the sk plus 1? Yeah, that's your rough draft. And then in your final draft, that's all you have to get to. Yeah. Okay, let's do another one. Let's do it. Okay. Alright, this one's fun. Write small. Here we go. Introduction. Let Sn equal 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared equals n plus 1, 2 n plus 1 all over 6. Okay? Step 1. Oh my god. Okay. Here we go. Step 1. Yeah, S1. Yep. S1 is 1 squared, which should be 1 times 1 plus 1 times 2 times 1 plus 1 over 6 is true. Just writing it a different way than last time. Okay. Step 2, my favorite. Assume SK, which is 1 squared plus 2 squared plus 3 squared plus dot 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 plus k squared equals k plus 1, 2k plus 1 all over 6 is true. Okay. So by adding, hello? Yeah, by adding k plus 1 to both sides. That's the third step. Right? You would have 1 squared plus 2 squared plus 3 squared plus dot 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 plus k squared plus k plus 1 squared is equal to k plus 1, yep, 2k plus 2k plus 1 all over 6 plus k plus 1 squared. Again, just add k plus 1 squared to both sides. And you already did the pregame, so you know what you're supposed to get up to, right? So basically, you simplify that right side, and get to that point. We're good. There we go. Common denominator because we're adding 6. So you agree that this is k plus 1, 2k plus 1 plus 6 k plus 1 squared all over 6. Yay? GCF. Over. Nice. Yeah. K plus 1 over 6. That just leaves k times 2k plus 1 plus 6k plus 1. True. Okay? If you were to simplify the inside, where your algebra comes in, don't astray. Plus 1 over 6. Yeah? 2k squared plus k plus 6k plus 6 on your base, which simplifies to k plus 1 over 6 times 2k squared plus 7k plus 6. Can you do it without writing that? It's definitely 2k and k. 2k plus 3 and plus 2, because that would be 4 plus 3 is 7. So the first one is 2k, so 2 and 2. And then you kind of play around with 6. It's either 1 or 6, and then 2 or 3, right? And try to get to 7 by doing the outside and everything. But if you're comfortable slide and divide, do it. Okay? This, make it 12. And we could try 12. 12 is 2 and 6. Wait, 3 and 4 to make 7. Then divide by 2, blah, blah, blah. Yeah. It's a good time. All right. Is that it? Yeah, it is. Here we go. 2k plus 3 and then k plus 2 divided by 6. Was that what we got for the last one, or in some form? Yep. This is equal to sk plus 1, right? Check. Therefore, by mathematical induction, Sn is true for all positive integers x, blah, blah, blah. Yay? Ooh, I like this one. All right. Notice I gave you the whole page. Questions yet? Go too fast. Okay. All right. Here we go. Proving that 2 is a factor of n squared plus 5n. Goodness gracious. All right. Introduction. Let Sn be 2 is a factor of n squared plus 5n. Okay. Step 1. Oh goodness. S1 would be 2 is a factor of 1 squared plus 5 times 1, which is equal to 6. Therefore, S1 is okay. This one's a little different because it doesn't have all of the pluses out. This is will show you the changes. Alright. Step 2. Assume SK is true. Right? And let SK be 2 is a factor of k squared plus 5k. Yeah? So step 3 would be sk plus 1 is 2 is a factor of k plus 1 squared plus 5 times k. Yeah? Oh, yeah. Okay. So if you were to simplify that, k plus 1 squared plus 5, oh, it's 5 times k plus 1. Sorry. Right? 5 times k plus 1. If you were to work that all out, k plus 1 squared is k squared plus 2k plus 1. True. Plus 5k plus 5. Okay. Now, this is k squared plus 6k, 7k plus 6. Yeah. Okay, hang on. Let me show you this little thing, right? So you got k plus 1, k plus 6. But we can't show that 2 is a factor of either of those. So here's the trick part. Okay, so here's what you do. Alright. Go back to this. Okay? Can you factor that out of this? Well, not factor, but pull it out of it. So, would you agree that this thing is the same as if you just take this part? Ready? Is going to be k squared plus 5k plus, if I took 5k out, then you have 2k plus 6 left over, right? Here's the genius. This is sk. We assume sk is true. So this is already true. Is 2 a factor of this? Yes. So if 2 is a factor of sk, because we assumed it was true, and 2 is obviously a factor of the next thing, then it's a factor of the whole thing. Hey, I know. Okay, so here's what I just said, right? We said 2 is a factor of sk, because we said that was true from the start, right? Over here, 2 is a factor of 2k plus 6. Therefore, 2 is a factor of sk plus 1, which makes it true. Thus, Sn is true, dot, 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 for all positive integers and yada, yada, yada. Okay, so the trick to this one is to pull the sk from the original. All right, we got a little bit of everything to practice for the evens, yeah? And it's a little daunting, that's why I'm starting now, so we have less. But we can, I'm just going to pull like 3 questions from the board. Every question is related. I think one of us should know this actually. All right, here we go. Donut worry. Abby brought donuts. Yeah.